What if a black hole changes more than space? A black hole is often imagined as a cosmic monster, a dark mouth in space, a thing that swallows everything and leaves nothing behind. But that image is too simple, because near a black hole, the strangest thing is not only that gravity becomes extreme, it is that gravity begins to reshape time, light, distance, and even your sense of what reality is. The closer you get, the less the universe behaves like the solid, stable place your intuition expects. And that raises a deeper question. What really happens near a black hole when time, gravity, and reality itself stop behaving in familiar ways? To understand that, we have to begin with something that is already scientifically established. Gravity is not just a force pulling objects together in the old, simple sense. In modern physics, especially in Einstein's theory of relativity, gravity is better understood as the warping of spacetime itself. Massive objects bend the geometry around them, and smaller objects follow those curves. For everyday life, this effect is tiny. Earth bends spacetime, but not enough for us to notice directly. The sun bends it more strongly, which is why planets orbit it. But a black hole is where this bending becomes so extreme that the normal rules of experience begin to fail. A black hole forms when enough mass is compressed into a very small region. In many cases, this happens after a massive star collapses. If the remaining core is dense enough, gravity overwhelms every known force that might resist it. Matter is crushed inward. The result is a region where escape becomes impossible once you cross a boundary called the event horizon. That phrase matters. A black hole is not simply a hole in the ordinary sense. It is a region of space-time surrounded by a point of no return. The event horizon is not a physical wall, and it does not have a hard surface like rock or metal. If you were falling toward it, you would not necessarily hit anything at that boundary. Yet once you pass it, every possible future path leads deeper inward. This idea became more than theory through evidence gathered over decades. Astronomers have observed stars orbiting an invisible object at the center of our galaxy, revealing something with enormous mass packed into a tiny space. They have detected gravitational waves from black holes merging. And in 2019, the Event Horizon Telescope released the first image associated with a black hole, followed later by the image of the one at the center of the Milky Way. These were not photographs of the hole itself, but of the glowing matter and light being distorted around it. Even that was enough to show that these objects are not science fiction. They are part of the real universe. So what happens if you go near one? The first answer is simple. Gravity changes the flow of time. This is one of the most powerful and unsettling results of relativity. Time is not absolute. It does not tick at the same rate everywhere. The stronger the gravitational field, the slower time passes relative to regions farther away. This is called gravitational time dilation, and it has been measured even here on Earth using precise clocks placed at different heights. GPS satellites also have to account for relativistic effects, or their positioning would drift. Near a black hole, this effect becomes enormous. Imagine a person approaching the event horizon, while another person watches from far away at a safe distance. The falling person experiences time normally from their own point of view. Their heart beats, their thoughts continue, their watch ticks as usual. But to the distant observer, the falling person appears to slow down more and more. Light leaving them becomes stretched to longer wavelengths, fading toward red. Their image grows dimmer. They seem to freeze near the horizon, never quite crossing it. But from the falling person's perspective, they do cross it. This is where reality splits into two valid descriptions. The outside observer never sees the crossing completed in ordinary visual terms. The falling observer experiences no magical pause at the horizon itself, assuming the black hole is large enough that local tidal forces are not immediately fatal there. Both viewpoints are consistent within relativity. Reality near a black hole is not like a single movie watched by everyone from the same camera angle. It is more like a map that changes depending on where you stand and how you move through it. The second strange thing is what happens to light. A black hole does not only pull on matter, it changes the paths of light itself. This means the region around it can bend, distort, magnify, and trap light in bizarre ways. If you were near a black hole and looked outward, the stars behind it would not appear where they really are. their light would curve. The sky could look warped into arcs and rings. Some directions might show multiple images of the same object. This is gravitational lensing, but near a black hole it becomes extreme. Space stops acting like empty distance and starts acting like optical machinery. The universe becomes a distorted mirror. That matters because human perception relies heavily on light behaving predictably. We trust vision because in normal conditions, light travels in ways that make space feel stable. Near a black hole, that stability collapses. Up, down, near, far, behind, ahead, these stop feeling reliable. Reality becomes harder to interpret, not because the universe has become unreal, but because our usual interface with it has broken. The third effect is the growing violence of tidal gravity. Gravity is weaker with distance. Near Earth, that difference across your body is tiny. Near a black hole, the difference between the pull on your feet and the pull on your head can become enormous. This is what creates the famous idea of spaghettification. You are stretched in one direction and compressed in another. For a smaller black hole, this could happen before you even reach the event horizon. For a supermassive black hole, the horizon may be crossed before tidal forces become extreme, because the gradient there can be gentler at the boundary itself. Either way, deeper in, the stretching becomes catastrophic. This shows something important. A black hole is not dangerous merely because it pulls hard. It is dangerous because it pulls unevenly. The structure of your body depends on nearby parts of you sharing almost the same motion through space. Near a black hole, that shared motion is torn apart. The fourth effect is that the idea of escape begins to lose meaning. In normal life, escape is just moving away. If something is dangerous, you turn around and leave. Near a black hole, especially once inside the event horizon, away stops being a useful direction. The geometry of spacetime has changed so deeply that moving toward the center is no longer like choosing a path on a map. It becomes as unavoidable as moving toward tomorrow. Outside the horizon, you can still imagine choices. Inside it, all future directed paths lead inward. This is one of the most shocking things black holes teach us. Some regions of reality are not prisons made of walls, but of structure. You are not trapped because something blocks you. You are trapped because the shape of reality gives you no future that leads out. The fifth effect is philosophical as much as physical. Black holes force us to confront the limits of intuitive reality. We evolved to understand medium-sized objects moving slowly in weak gravity. Our brains are excellent for throwing stones, reading faces, judging balance, and avoiding cliffs. They are not built to naturally understand curved space-time, frame-dependent time, or horizons beyond which causal connection breaks down. A black hole exposes that mismatch. It reveals that reality is not obligated to be comfortable, visual, or intuitive. And this has consequences beyond astronomy. If black holes are real, then reality is deeper than appearance. Time is not the same everywhere. Space is not empty emptiness. Light does not always tell a simple truth. Observation depends on position. Even the meaning of now becomes unstable when gravity and motion become extreme. If that is true, then the universe is not a static stage where events happen. It is an active structure that shapes the events themselves. And if that is true, then many things we treat as fixed may actually be local habits of reality, not universal rules. This is where the psychological implication becomes surprisingly powerful. Black holes remind us that human intuition is not the measure of truth. Something can feel impossible, absurd, or unreal and still be scientifically correct. That matters because so much confusion in life comes from assuming that what feels natural must be what is true. But reality often exceeds instinct. Science advances precisely when we are willing to examine the world beyond the limits of immediate perception. Black holes also change how we think about scale. In ordinary life, we imagine the universe as mostly empty and calm, with a few dramatic events scattered through it. But near a black hole, the hidden architecture of the cosmos becomes visible. Time stretches, light bends, causality tightens. The ordinary assumptions of daily life are revealed as regional conditions, not cosmic law. And perhaps the strangest implication of all is this. A black hole is not just an object sitting in space. It is a place where the relationship between observer and universe becomes impossible to ignore. What you see depends on where you are. What can happen depends on geometry. What time means depends on gravity. So what happens near a black hole? Time slows, light curves, space distorts, escape disappears, and reality reveals itself to be far stranger than the version we experience on Earth. A black hole does not just challenge physics, it challenges human certainty. It shows that the universe is under no obligation to make sense at first glance. And maybe that is the real lesson waiting at the edge of the event horizon. The deeper we look into the darkest places in the cosmos, the more we discover that reality was never as simple as it seemed. Lucid order. Question everything.